new about this device is that it has 8 arms. But actually, it's really not an 8-armed Fixator. This device, in many ways, is much more similar to the Lazarov device than it is to the Taylor spatial frame device. If you look at it, don't look at the oblique arms, look at the vertical arms. What do you see when you see 4 vertical arms? It's very much like many of the conformity constructs from Professor Lazarov's device. And you remember when we used to move things with the Lazarov device, sometimes you have four devices with hinges at the end and you move them. We tend to think in quadrilateral intuitivity. Why do we always get AP and lateral X-ray? Not so much oblique X-rays as we think this way and this way. Most things we do are in a sort of a grid, XY grid. And that's what this device is acting. So theoretically, you could adjust these 4 struts and move this ring intuitively, while if you took a hexapod type platform, it's hard to, if I move this one, what happens? If I move this one, what happens? You can do it, but it's not so easy. With this, it's like when you're adjusting the Lazarov. There are certain advantages of that. Certain advantages of that also in terms of radiographics. When you do an AP, you have a big window. When you do a lateral, you have a big window. You might say, no, these take up more space. These are never where the osteotomy is. The osteotomy is here. It's in the clear zone. You have one end of this device that has a lot of mobility, and one end that is more constrained. And that's why, although you don't need to color the rings, just to make it easier, you have a moving ring, and you have a reference ring. It's also a very smart idea. So, you know, with the TSF, you can decide to put the reference ring at one end or the other end. In this one, the reference ring is always on the diaphyseal segment. No matter what, you're always putting one ring on a diaphysis, the other ring, or on a diaphysis, or on a metaphysis, right? What's easier? Is it easier to put perpendicular pins to a diaphyseal segment, or put perpendicular to a metaphyseal segment? It's much easier to be perpendicular to the diaphyseal segment. So this is the reference ring, and most people with an image intensifier or even freehand can put 2 pins perpendicular to the bone and mount this ring. So just like the PSF, it's not absolutely necessary to be perpendicular, but the more perpendicular you are, the planning, when you talk to the computer already assumes that this ring is perpendicular. The computer does not assume that this ring is perpendicular. Just like with the Lazarov and with TSF, we try and put the second ring as perpendicular as possible, but it doesn't have to be perfect. So we color-coded so that the red is your reference ring and black is your moving ring. Okay? The moving ring is only connected to 4 spots. The reference ring is more constrained, is connected to 8 spots. Okay? You can actually remove 1 or 2 of these, and the frame remains stable. Okay? If you remove all 4, it's unstable. But if you remove just 1 because you need to get in, it remains stable. Okay? All right. So the other thing that's kind of nice with this, and I know we've played with this back and forth. You know, we started off with the Lazarov. You went the Russian technique. You put wires, ring, connected them together. Then we went to pre-construction with the Lazarov, and that was kind of nice. It made you think, it forced you to plan. You come to surgery with a frame, and you sterilize the frame, and then you put it on. Then we did the TSF. We started with the chronic frame, which was a pre-constructed frame. But it did get it exactly perfect. It wasn't so good. When we went back to the Russian technique, I call it the Russian technique, where you put your pins in, ring, and then connect them together. This frame is more convenient to use the pre-construction approach. Okay? It's a little bit of a frame in a box. So when you get a TSF, you have to put everything together. This takes time. When you get this, you basically only have to decide the ring size and the overall strut length. So you say, okay, I want, basically it's like saying I want a small, medium, large, or whatever. There's also a pediatric version of this, which is downscale. And when you do that, this comes fully assembled. You don't have to put, you're thinking, oh, what a nightmare. It's bad enough putting 6 struts on, now I got to attach 8 struts and all these. This comes already assembled. Okay? But you have to choose which size. You want the small, medium, large, kind of thing. Comes assembled. When you buy it from a company, I call it a frame in a box.
So you get the size.
What?
Here.
The box. It's here. Oh. You get the box. The great thing is you get to keep the box, and you can, put the spare parts. It literally, here's what you get from the company. Okay? It doesn't come with an angle. So now you're sitting. Okay, this is a small strut, smaller ring. Okay, but you can request anything. You can request any combination. You can also build it. If you really want to build it, you can build it, but you make yourself a little crazy. I don't have time. Now you sit here and you adjust this approximately to the deformity. Because of the quadrilateral, you have this point which is anterior. Okay, so you already have a definition anterior. You know right or left, and all you need to do is say, okay, I need to tilt this ring about like this, this, and this. Build your frame to what you want. You can also then put it onto the leg to get this out. Put my pin right there. Put a plate, cube, and cut it off so it's inside the frame, and then put this back. I think the point of removing this is the frame is not unstable by removing this. You don't lose any position. So you have some flexibility. Make small changes. You've done your osteotomy. And let's say there's some changes you want to do right then. You don't have to unscrub, do a calculation. It's so intuitive that simple movements can be treated acutely. So translation, for example, all you have to do for translation is take any 2 of these and adjust. Nothing else moves, and the whole frame tilts, right? So if you want this to tilt that way, you shorten this, you lengthen this. If you want it to tilt in the other one, okay? If you want to compress, obviously, it's just like in the Lazaro. It's pure compression. With TSF, you never know how much movement you get because 1 millimeter of shortening here is not 1 millimeter this way. Okay? When you're starting here, 1 for 1. You want to shorten, lengthen. So for simple shortening and lengthening, I think this is more convenient. You did the Zaroff that I thought, what do I need this? The big advantage is truly a fixer in the box. And this frame comes like this in a box. Actually, comes parallel rings, all constructed. This is actually one of the advantages of this system, is that it is pre-constructed for you. The only adjustments that are made is that the moving ring is adjusted approximately to the angle of the deformity. It's adjusted in a very simple way. Forget about these side struts, think of only the 4 struts. That's what we did with the Lazaro. With Lazaro, we had 4 struts, hinges, we adjusted it up and down, and as long as you know the anterior posterior axis, which is this one, where the plus is, it says anterior. It doesn't need to leave anything to the imagination. So that's anterior. We've got the 4 struts in the 4 corners. This is what he was referring to with quadrilateral intuitivity. So we're used to working with anterior posterior and medial lateral frontal and sagittal planes, and because we're used to thinking that way, biplanar, the Lazaroff was very easy for us because it was intuitive. You can look at the Lazaroff device, you know what its function, what it's doing. If it's lengthening or rotating or angling. When you look at six-axis fixators such as Taylor spatial frame, hexapod, you don't know what it's doing. Only the computer knows what it's doing. So you can guess that if I turn this, maybe this happens. But it's not so intuitive. It's not so obvious what it does. So one of the things I do a lot of Taylor spatial frame. And one of the things I from the Lazaroff is the quadrilateral nature of the frame. So even to make a small correction, I always have to go to the computer, even just for lengthening. In other words, with the Taylor spatial frame, two rings parallel, I don't know how to lengthen it. You have to go to the computer and it will tell you how much to turn for lengthening at a certain rate, because when the struts are at an angle, you know. One of the advantages of this construct is it's more like the Lazaroff. I know it looks like an octopod, 8 arms, but actually it's a quadrupod. It is more like the Lazaroff. It really only has 4 arms. And I like to think of the side arms as braces. They're the support. And these ones are helping to support the position of these vertebrae because there's a hinge at each end. With the Lazaroff, it would be locked in one place and only a hinge in one place, but uniaxial hinge, so it was stable. This is a universal hinge, can move in all directions. So if we remove these 4, this is completely unstable. If you remove 1, it's still stable. Okay? Once you get more than 1, you get into trouble with this thing in terms of stability. So, so one of the nice things I like is the intuitivity of adjustment. So the rings come in 2 colors. The red is the reference ring. Red reference R. Okay. The black is the moving ring. Okay, or the deformity ring. The plan is to put the deformity ring closest to the core, and the reference ring perpendicular to the diaphysis. So if before you fix the red ring, adjust the black ring just like this. So let's say I had a tibia vera, adjust the black ring, shorten here, lengthen here, to put this at the ankle. Let's understand the range of motion of this machine. So the range of motion of this machine is always twice the angle you see. Let's say this is the maximum. Okay? What's that? Let's say this was 45 degrees. Let's say the maximum is 45. So the range of motion is 90. So you put this like this. After 45, you're there. You could go if you had a very large 45, you're there. You could go if you had a very large deformity, another 45. That's why you want to match this ring to, it doesn't have to be exact. In fact, for the planning, the angle of this ring doesn't matter because you will be telling the computer digitally where this ring is. It's more a practical question to put the ring in the maximum direction so you have more range of motion after you start the correction. Okay? So you're never limited. You don't want to be limited by range of motion. You understand? It minimizes your strut changes, et cetera, et cetera. So remember, you don't want to put the red ring in the wrong position. You can still do the planning even if it's upside down. The problem is, if you notice, the red ring is more constrained. It cannot do as much range of motion. That's actually one of the things that's different here. The hexapod or the TSF is that with hexapod or TSF, both rings are moving relative to each other the same amount. Here, it's really the black ring is moving more in total range because it's not constrained by the side arms. Then TSF. TSF, you take your X-ray relative to what you call the reference ring. Is that also in hexapod? Yeah, so in both systems you name a reference ring, and then you take your X-rays relative to the reference ring. Here the reference ring is used in a different sense. It's not the one you take the X-rays from. It's the one you reference to the position of the frame. Now, what's interesting, and then once you've uploaded the system, saved it, you can proceed with digital planning. Now, one thing you can do in this system before you take your X-rays, is you could adjust this translation, compression, extraction, angulation, rotation just manually, intuitively. You only have a small amount. I wouldn't waste your time with all the computer. And that's one advantage of the system, is that it's like the Lazaro. You have that small adjustability. To do, for example, compression extraction is very easy. It's 4 rods up and down. To do translation, think about it, it's not so hard. Translation, there's only 2 horizontal. These things are anterior, posterior, medial, lateral. So to do anterior, posterior translation, it's always going to be this one, always going to be this one, and this one, right? Without touching any of the rest. So you would, because they're in opposite directions, one of them is going to shorten, the other one's going to lengthen. And that's translation. Translation this way, one's going to shorten, one's going to lengthen. If you lengthen all of them, what's going to happen? Rotation. Remember the Lazaro method? So those of you who like Lazaro but want to make a jump to 6-axis, this has a little bit of the best of both worlds. Hopefully, if you're experienced with it, it won't end up being the worst of both worlds. But I think it has actually a little bit of the best of both worlds. Okay, so that manual intuitivity is one of the few things I love the Taylor's vision. I love all that stuff, but I miss the intuitivity of the mechanics. I really miss that.
You never have a problem seeing your osteotomy, like with the Lazaro when you have 4 rods. Because
where you have a lot of traffic is not where the osteotomy is. So where you have only this part of the bar, it's like with the Lazaro, is where the osteotomy is. Remember, I told you, always put the black ring near the cora, so then you can always see here. So yes, in this area, a lot of metal. This area is not important to see. Anyway, you know, when you have a TSF, one of the problems is just putting pins in without getting the struts. But where do you have the most problem? In the metastable segment, where you have only a small space. Where you have the least problem? In the long diastole segment, where you have so much choice. You have a lot of room to put pins, just like with the Lazaro, in the metastable segment. And the diastole segment, which has a lot of strut, but you have so much space because it's a big piece. So one of the advantages is that with a little bit less theoretical problem with ring and pin collisions. Don't worry about the small pieces now, because those things can be added to any system. And you can use the cubes you have now with this system.